Symmetry. When a straight line divides a shape into two identical shapes, the shape is symmetrical about the line. The line is called the line of symmetry. If a shape can be divided into two halves such that the two halves are mirror images of each, then the shape is symmetrical. One half is the reflection of the other half. It is called reflectional symmetry or mirror symmetry. A regular polygon of n sides has n lines of symmetry. Solids are three-dimensional objects such as stones, cones, boxes, etc. If an object can be cut into two halves, which are mirror images of each other, then the object has plane of symmetry. The plane separating the two halves is called the plane of symmetry. A sphere has an infinite number of planes of symmetry. A solid has rotational symmetry when it shows the same orientation after rotation around an axis through an angle less than 360 degrees. A regular solid such as a tetrahedron has an axis of rotation. Solids can have more than one axis of symmetry. The order of rotational symmetry of a regular polyhedron is 360 degrees over n, where n is the number of sides of its base. Examples: 2016. The diagram below shows a right pyramid with a square base ABCD and apex P. How many planes of symmetry has the pyramid? So, since the pyramid is a square and the square has 4 lines of symmetry, it means that the pyramid has 4 planes of symmetry. It can be cut through DB, it can be cut through AC, it can be cut through DC and AB like that. It can also be cut through AD and BC like that. So, a pyramid has 4 planes of symmetry when the base is a square. 2017. The diagram below shows a cone with apex V and radius R, like that. How many planes of symmetry has the cone? Since the cone has a base which is a circle and the sphere has infinite number of planes of symmetry, so we can say that since the cone has a circle at the bottom here, it has infinite number of planes of symmetry or uncountable number of planes of symmetry. 2018. The diagram below shows a triangular prism with AB equal to BC equal to AC equal to DE equal to EF equal to DF and AD equal to BE, which is equal to CF, like that. State the number of planes of symmetry of the prism. Now, this prism has triangular faces, and the triangular faces are triangles of an equilateral. An equilateral has 3 lines of symmetry. So this plane must have 4 planes of symmetry because it can be cut passing through C, passing through A, passing through B, and even there in the middle. So we can say that the prism has 4 planes of symmetry. We go to 2019. The diagram below shows a plane figure made up of congruent semicircles, angle AOB equal to 90 degrees. I'll read that again. The diagram below shows a plane figure made up of congruent semicircles, angle AOB equal to 90 degrees, like that. Describe fully the symmetry of the figure. Describe fully the symmetry of the figure. Now, figure ABCD has a rotational symmetry of order 4 about center O. It can be rotated 4 times so that it has the same orientation, or where the semicircles will be able to fit on themselves. Now, they can only fit on themselves at an angle of 90 degrees, which is 360 over 4. So it will be able to fit on itself 4 times. As simple as that.